All right, so example 4 says that body temperature varies over time, and it apparently is about a 24-hour cycle. Right, so if you look at the distance between these peaks from 6 to 30, that's a 24-hour period, right? So the period of this cycle is 24 hours, okay? I guess that kind of makes sense. Maybe your body temperature falls at night and then comes back up during the day, and then cycles. And it's a fairly small range. It's varying between 36.2 and 37.4. Now you can see, it's kind of hard to see here, but we have a little break in the axis here. So that's one, little tip when you've got data where you're plotting something in a very small range, but it's not even close to zero. They're just breaking the axis here, so they're not showing a bunch of values that are below 36.2. All right, so we want to find a formula for this function. Well, we can easily see that the midline, let me write this down here, the midline looks like y equals 36.8, right? Let's write it again here. Y equals 36.8, right? We can also find the amplitude. Amplitude, it's just the distance from the midline up to a peak, right? So the distance here goes from 36.8 to 37.4, so it looks like that's about 0.6. And our period is 24 hours. All right, so we've got all the information we need. We just need to put this together into a formula. Now you can use this information here in this gray box. I sort of left it up here, and you can use that. Now, if you look at this function, let me just highlight one cycle. We're starting low, and then starting at zero, or starting at the midline, I should say, starting at the midline and ending back up at the midline. So this looks like a sine function. So I want a function that's going to look like y equals a sine of bt plus k. So a and k are easy, right? Because this amplitude, this is our a value, right? This is our k value. And now we just have to figure out what the b value is. Okay? Now I could come back up here and say the period is 2 pi over b, so I know that the 24 is our period, and 2 pi, that's equal to 2 pi over b. So it looks like b is going to be pi, b is equal to pi over 12. Okay? Now, if I forget that formula, which you shouldn't forget it because you can have a reference sheet. What I would do is I'd probably just say, okay, let's look at bt and let's look at t. I know that one cycle is going to go, from 0 to 2 pi, right? The input because bt is the input to the sine function, right? So, and sine cycles over a period of 2 pi. So what does t have to be, right? So when t is 0, bt is 0, but I want bt, right, at the end of the cycle, so b times 24 to be equal to 2 pi. So I can get the same thing that way, pi over 12. So either way, because it just should be 24, right? The one cycle happens from 0 to 24. And in order to get that, the input to the sine function has to be 0 and 2 pi. Okay? Either way. All right, so let's put this all together. And our the function for this that describes this graph is y is equal to, okay, it looks like, so the amplitude is 0.6, right? Sine of pi over 12, and there's t, and then plus the k value, which is plus 36.8. Okay? So you can always check it. You can always check yourself if you're not sure if that's quite right. Put some values for t in, right? When t is equal to 0, I should get 36.8, right? Because that's where I'm at 0. And the same way at t equals 24, if I put in 24 for t, this pi over 12 times t becomes 2 pi. And again, I'm going to have 36.8. So, and I could check any other point in between too. Like, so at 6, I should be at 37.4. So if I put in 6 for t, I'll end up with pi over 2. Sine of pi over 2 is 1. So 1 times 0.6 is going to give me 0.6, and then add that to 36.8, and I end up with 37.4. So I can check a few values if I'm not sure. But this is the formula for that function. All right, let's see. I'll meet you in the next video.